Welcome to some practice problems regarding the federal debt per capita and the Consumer Price Index, the CPI. So first we're going to start here, number one, always a good place to start. At the end of 2012, the federal debt totaled $16.1 trillion. That's a little bit of money. And part A here, calculate the U.S. federal debt per capita for 2012 using a U.S. population of 314 million. Now the first thing I want to point out is that we're talking about per capita. Remember that per tells us to divide and capita tells us, talking about people. So in words, this problem talks about the federal debt. Per tells us to divide and capita tells us people, right? So federal debt is 16.1 trillion. Well, 16.1 trillion means times 10 to the 12th. I know that's not scientific notation, but I'm just going to go with the numbers they give us. Now, the population is 314 million. Million means 6. And we could change these numbers to scientific notation, but it's not crucial to the mathematics behind this problem. Now, when we go ahead and divide this, if we first and just divide 16.1 divided by 314, our calculator is going to spit out 0.051273885. 4. It's beautiful, right? Then we have our times. And if you recall, when you divide with the same base, in this case our base is 10, we subtract our exponents. And 12 minus 6 is 6. Now that's a great number in scientific form of scientific notation here. But nobody talks like this. Nobody says 0.05 times 10 to the 6th. So let's go ahead and change that to be a number like we're going to talk about, standard form. So I'm going to move my decimal 6 places to the right because 6 is positive. My number is going to get bigger. So 1, 2, 3, 4, 5, 6. That gives me a federal debt per capita of $51,273.89, right? 2 places. I look 1 place past that 8, 5 rounds up, and that gives me 89 cents. So our federal debt per capita, so per person, is over $51,000 in 2012. All right, let's go to part B, which builds on this problem. How does the U.S. federal debt per capita compare to the U.S. per capita income of $42,693? So our federal debt per capita, as we just found, is $51,273.89. Well, if we want to find how that compares, let's subtract the income. So this is debt, this is income. When I subtract those two numbers, I get $7,580.89, meaning our debt is greater than our income by $7,580.89. People, we can't live like this, right? Personally, you can't bring in over $42,000 and spend over 51 on a yearly basis, right? That doesn't work. Now, it might happen one year if you have, medical issues or your car dies or whatever, but year after year, this is not sustainable. You can't live like this, and yet the federal government does it every year. All right, let's move on to CPI in our CPI table. You recall earlier in our packet on page 44, we've got a more extensive annual CPI from years, I believe, starting in like 1977. This particular problem here, we're just going to kind of focus on these. We will, when we get to number 5, go back to page 44 for a value. So first of all, let's use this table to find the annual CPI for 2015. Well, it's right here. Right, 237.017. And what does this value mean? Well, if we turn this to dollar amount, which means 2 decimal places, 7 rounds up, this kind of represents 237.02. So that means a basket of goods and services, right? So the goods and services represented by this would cost 237.02 in the year 2015 compared to any other year. On page 44, we compared in 1983, the basket of goods and services only cost $99.60, or, right around $100. So from 1983 to 2015, our basket of goods and services more than doubled. That's what our 2015 value really tells us. And now let's do some CPI work. How many years after 1983 did it take the value of goods and services to go up by half of their values? Well, as I mentioned in 1983, I'm going to round and say it's approximately $100. So to go up again by half, that means we're looking for 150 because half of 100 is $50, so we're looking for 150. And if you look at the CPI table on page 44, you will see that approximately in 1995, we have a value of 150. This just shows you that in 12 years, the values went up, again, by half of their value in 1983. From the previous CPI table, is there any evidence that there's been a decrease in the value of goods and services? So I'm just going to backtrack, and we're looking at this table. So you're kind of comparing month to month, year to year. Are there any decreases? Now, hopefully you can kind of check this out, but you'll notice here, I believe in July of 15, we're at 238,654. Notice how it goes down slightly, So here at the end of 2015, from July to December, our values decrease, right? Starting in July and after that, the decrease happens. But when you then go up to January of 2016, once again, we're on the rise. And then they continue to increase month to month after that, I believe. For the most part, here's a little bit of a decrease again from October to November of 16. But overall, we have increase after that. Okay, so approximately August to December of 15. All right, now let's get to some math. The median value of houses sold in the state of Indiana in 2011 was approximately $130,000. What was the comparable median house value in 1995, assuming the housing market followed inflation? All right, so we're comparing 2 years, 2011 and 1995. And you are going to need page 44 for these CPI values. Recall that we're going to put dollars on the top and CPI values on the bottom, because that's how I like to set them up. Again, with proportions, you have 4 different ways you can set up every proportion. This is just how I set my CPI problems up. So when we're looking at 2011, the cost was $130,000. And when I look at my CPI table in 2011, my CPI value is $224,939. And I get that value from page 44. Now, in 1995, I don't know what my dollar amount is. That's what I'm trying to find. But according to my table on page 44, my CPI value is 154.2. So recall, solving a proportion, we cross multiply. And I end up with 224.939 times x equals, and when I multiply the 130,000 times 152.4, I get 19812, triple zeros. Divide both sides by the number in front of x. I'm running out of space here on my paper, but I get an x value of, and again we're talking dollars, so I'm going to round to the nearest penny, $88,077.21. Anytime you're dealing with money, you want to round to the nearest penny unless otherwise stated. And the last problem, we're going to compare a house in Indianapolis that was worth $77,500 in 1986 and comparing that to May 2017. So again, we're talking about 1986 compared to 2017. We want dollars on the top, CPI on the bottom. Now in this case, in 1986, we've got dollars of $77,500. I look at my table on page 44 and I get 109.6 for my CPI value. When you compare that to 2017, I don't know the dollar amount, but notice how they say May of 2017. Since they give you a specific month, you want to use that specific month, which is 244.733. And that comes from the table slightly above this on this page, right? The table that's between 3 and 4 on the page. And again, we cross multiply. So 109.6 times x equals 1896687.5. Divide by the 109.6. And again, I'm out of room. I need to really work on that. I end up with $173,054.81. So a $77,500 house in 1986 is more than $173,000 in 2017. And that is your practice page on the federal debt and the CPI.